be testing. And we have also the King Saud University that will be testing at high ambient. That's in the Middle East. We have several other companies that will be testing at high ambient in the United States. So if you are interested in testing at high ambient, you're a manufacturer, you're in a university, please get in touch with us, because I think we need more manufacturers in the Middle East to test at high ambient. You can see the refrigerant that will be tested at high ambient. We're testing both at 46 and 52 degrees Celsius, and most of them are type of residential equipment, but you have also some rooftop units as well. That will conclude my presentation. I would like to acknowledge those who participated in our program, and thank you very much.
Thank you, Dr. Karim. So now we present Mr. Bassam Al-Assad. He's a mechanical engineer with a career in the HVAC industry. He is the chair of a European subregion for ASHRAE and member of UNEP Refrigeration Technical Option Committee, RTOC. He is currently focused on working with UNEP and UNIDO on projects related to phase out of ozone depleting substances and introducing low GWP refrigerant alternatives. Mr. Assad is coordinating consultant for the Praha project. So the title of the presentation of Mr. Assad is Promoting Alternative Refrigerants for High Ambient Countries. The floor is yours.
Thank you, Marco. I'll try to use the same tactics as Karim and say in the next 25 minutes, I'm going to talk to you about Praha. Actually, thank you for Shamila and Stefan for introducing Praha. The project started from the region here after the first meeting and actually took off at that time. The progress has been steady, and today I'm going to go briefly over the project very briefly, because I think most of you know about it, tell you about the progress and the linkage of the project to the theme of our conference today. Well, what is Praha? Actually, we wanted to Praha wanted to do a couple of things. We wanted to assess the available technologies, link that to energy efficiency. You've heard about the minimum energy performance standards that are being introduced in the region, and the importance of the linkage between the alternatives that are going to be available and those standards. And then we're going to see whether these alternatives are practically viable. So these are the project elements as they are. There are a couple of studies also linked to the project. So that has 4 elements in it, and the elements are the testing of the prototypes, the studies linked to the economic and the viability of the project, the comparison of these, and then basically the promoting the technology transfer. Because if we do all this without having a mechanism of promoting this technology transfer, we go nowhere. So what is the prototype testing? Let me start by telling you what Praha is and is not, because you've heard about AREP, and you might think that there's a lot of similarities. Sometimes when I meet those of you who know Lambert Kuipers, of RTOC Antwerp, every time he meets me, he has a favorite joke, and he says, "So which refrigerant are you promoting?" And we tell him we're not promoting one refrigerant, we're actually testing the prototypes, we're promoting the idea of low GWP refrigerants. So we want to test the prototypes working with the alternatives, we're not testing about the characteristics of the alternatives. And there will be no recommendation, it's just a comparison. So this is very important. The other difference with AREP, and of course I'll tell you later about the relationship with AREP, is that we're testing prototypes that are custom built for these refrigerants. So actually the manufacturers are designing that basically from scratch, and it's not an optimized or a drop-in. We like this sentence we like this, let's say, catchphrase, that Praha is not a decision-making process, but a tool to assist in the decision-making. Thank you, Ayman, for that, because this is very important. I think we want Praha to be a tool to assist you in the decision-making. So Let me, I see a lot of people here, so if I may ask the people who are involved in Praha to stand up just to see the magnitude of the participation. Could you do that, please? Walid, yeah? Let's see. Okay, after the coffee break. Just wanted to acknowledge those people, wake you up a little bit. So there are 7 manufacturers from the region, and they are from the manufacturing countries, let's say, or countries with manufacturing capability in the region. They're also technology providers, and if you see those names and not others, it's not because we limited it by any means, but at that time we were looking for solutions that are readily available specifically for T3, basically on the compressor or whether it's on the refrigerant side, and components that can be available within a reasonable period of time. A lot of companies did cooperate with us on this project by working very hard and in a very short period of time to do it. So how did we select the alternatives? Actually, it was when we started talking, we're looking at R22. This is the region. The HPMP is about phasing out R22 from the region. But when you look globally, most of the countries, especially the developed ones, have gone beyond R22, and there's little research now linked to R22. Most of the countries, and you heard this morning about the HFC phase down, are trying to phase out HFCs, let's say, or phase down HFCs. So we were faced with a question, pressure-wise, whether we were looking at R22 equivalent or R410A equivalent. Of course, there are two different pressures there. And then we looked at the GWP, and you know that there are a lot of definitions about GWP, the low and the ultra low, and we wanted to put a ceiling. So we put 677. So those of you who know what this figure stands for know why more or less we're there in order to be inclusive of different technologies from the different regions. And then about flammability, because the first thing, we've been working with R22 for such a long time that we forgot that there are other factors that we have to look at, like safety and so on. So as a matter of fact, when we were looking for alternatives, most of the answers came for A1 alternatives. It's safe, you can work with it, it's not toxic, and so on. And we said, no, Oli here have a very important phrase, and a memorable one. He says we have to live with flammability. So we chose refrigerants that are mildly flammable or even flammable. And then about the applications, or what kind of units are we testing. So we looked at the market, not only at what's already installed, but also what the market trend is, because maybe one of these installed units or type of units, product families, could be on the way out. But so we compared both, and the HPMP is those plans for the phase out of 22 in the area, has a research aspect in it whereby you have a lot of statistics. So we use that, and then of course we have to take the varying cycles in the region, the 50 and 60 cycle. We wanted to make sure that they are manufactured by more than one manufacturer so that we can compare and take out the design aspect part of the particularities that are linked to one manufacturer. And wanted to make sure that it can be tested in one testing facility. So, because we're starting from window units all the way up to package units, we wanted to limit also the size so that they can fit within a testing facility, so they can all be compared, and when we take out the variation in testing. So that's why we limited the, so that's what we ended up with. Back? No? The red one. Okay, that's what we ended up with. We're not testing certain applications. For instance, the window unit for hydrocarbon or R32 for different considerations. We heard this morning from our colleague that there are windows with hydrocarbon, but this is maybe for phase 2, hopefully, and also not for the bigger units. And we're also comparing that to two base units. One is an R22, and the second one is an HFC based unit, whether it's a 410A or a 407C. So this is what we ended up with. We're looking more or less at 30 prototypes, and if we take the number of that each prototype has to be tested for more than one condition. There are 82 tests at different temperatures that are going to be carried out. Now, about the information sharing at the end, there will be a final report, and this final report will be shared with everybody. However, there are particularities about the test conditions that will be only shared with those people who are involved in it. Like, for instance, the particular test results for the prototypes, because of the confidentiality aspect of the project, we are only sharing with the manufacturer and the technology provider. And the NOUs will have a little bit more information. And there is a technical review team. I just want to remind the members of the team who are with us here today that there is a meeting following the Aramina meeting, so that's going to start at 6:30. It's going to be a long day for you, but please be with us at 6:30. And this team, they're going to look at the responsibility. That responsibility is the overall technical review of the final report. That's what we wanted them to be involved in. That was at the recommendation of the Multilateral Fund. And these people have sound technical background. I want to ensure everybody they're not related to any industry or to any technology. So, what's the timeline? Okay, we're very confident, and I show you a little bit some of probably the obstacles that we have. Still time? Yeah. 5 minutes? Okay. The prototypes are going to be finalized hopefully by the end of the fourth quarter. We had a bit of a delay in shipping some of the refrigerants. It's a learning curve. Now we know how to ship them, where to ship them, and the method. And several have already been made available, and I would like to thank the companies who worked really diligently on this. So the testing, and we'll talk about that tomorrow. There's a meeting for the stakeholders tomorrow about the testing facility and when does testing start. And Dr. Walid Shakroun is here, who's also advising us on the test methods. And hopefully we'll start with the report in the second quarter to be ready in the third quarter 2015, if everything goes according to schedule. So how is Praha contributing to the local research? Well, we heard from Dr. Shamila this morning about Rio Plus 20, about the future we want. Of course, the future refrigerants, well, it's about performance. I mean, basically, that's why we're here, because we want to make sure that they perform and they are also efficient. But it's also about sustainability. That not every couple of years, we're not looking for an interim solution. I think everybody knows that. We're looking at a sustainable solution that is cost effective and at the same time that conforms to the safety requirements or the safety standards of the region. So we coined another tagline about the research that we want and the future that we want. And this research, that's what we're saying, that's what the Praha is about. And it's just a reminder that it's about applications from the region, built and designed in the region, tested for standards of the region, and of course taken into consideration all the local best practices and operation, service, and installation of the region. So it's a very much regional project. Now the cooperation with Arab project, we said we're not copying Arab, but we're benefiting from the vast experience that they have in this field. And there is it's not a memorandum of understanding, it's a joint declaration of working together with Arab. And they've already provided us with the participants handbook. They're also going to provide us with more information about high ambient. And they will share with the results. Actually, Dr. Amran is a member of the technical review team. So what are the key messages? Well, couple of things. The alternatives should be sustainable. This is something that we don't want to repeat this. It's not an interim solution. We don't want to look for whatever is available on the market today. We want to leapfrog that and see what can fit for the region. And it has to conform to the maps. That's the actual, that's where we started. It has to replace 22 at the same time conform with the energy requirements. And we have to understand that we are working with flammability, and that's why this particular symposium is very important. Also, we have to think outside the box. I think Dr. Ala Olama asked a good question about not-in-kind technology. We have a part of the research is a research on district cooling and the effect of district cooling in replacing some of the R22 applications. So what are the lessons learned? At the beginning, when we started, we did not think that the project will have such attention from different levels. We're very happy with that response. We have a commitment from the manufacturers. I did mention that we face some obstacles. Now, the changing maps landscape in the area is forcing our stakeholders to work or to focus on some solutions that are immediate, because you've heard that there are things happening in 2015. Hopefully now they're being put back. I heard this morning that they're being put back a little bit. But that has maybe contributed to some of the delay that we have. And we also have a commitment from the international technology providers. You know, they're from everywhere, from the east and the west. We had a tour in Japan and China, and it was a very well prepared tour so that, you know, we could share with some of the technology that's happening there. And also, we learned about shipping those refrigerants. And this is very important because, you know, we're doing that ahead of time. We learned, you know, what to ship by air, what to ship by sea, and where, and how, what kind of applications we have to make, and so on. And the patents, well, it's a big mark. We're not going to talk about it today. I just put it as an item, food for thought or for future discussions if you want. So, Praha has brought up a couple of challenging questions. And it's basically that, you know, since we're doing the research in the region here, we want to know whether the market can accommodate more than, you know, several refrigerants. Everybody knows, I think you heard it from Steve this morning, everybody's saying not a single silver bullet. But however, we've been so much used to 22 that, you know, want to see whether we can do it with multiple refrigerants. And also, well, how can we deal with the complications of installation and service on flammability, on glide? When 407 was introduced, the glide was a big problem, but now we work it. Okay, and the other thing is that the big question is that, you know, now that we're doing the research on the prototypes, can we do something else, and can we be technology providers? When I say we, the region here, rather than technology recipients, and hopefully we can do that. So if you're interested, there's another project that's going to take place. We don't have time to talk about it, but please come and see us afterwards. It's going to happen in Egypt, and there's still chance for people to get involved. Thank you so much.
Thanks very much, Bassam, for this interesting overview of the project, and I guess all of us are very interested on the results. Hopefully they are available soon. I was particularly amused or puzzled by the illustration that you have on the review team with the American football outfit. You expect some heated sessions to evaluate? Well, last but not least, I would like to give the floor to Dr. Peter Armstrong. Dr. Armstrong is going to